Okay, welcome back. The next idea of clustering is what we call hierarchical clustering, and we'll talk about that idea in this video. So it's a method of clustering data into a hierarchy of nested clusters. There are two hierarchical clustering approaches. One is called the bottom-up approach, which will start with each data point as a cluster and then begin to merge these data points based on their closeness. The top-down approach starts with one single cluster and splits iteratively based on their distance from each other. The advantages of this algorithm is that it doesn't require the number of clusters to be specified up front, unlike in the k-means algorithm. So what is the concept in hierarchical clustering? It's a tree-like structure showing how clusters are formed. For example, when you take all the points, so there's a cluster of D and F, cluster of A by itself, cluster by C by itself, and cluster of B and E together. So we can determine how the distances between the clusters, how they are calculated. So for example, if you have a cluster here and a cluster here, and then you got points inside these clusters. And so how do we compute? If you have 2 points, then we know the distance between 2 points is, we can calculate it because we have the coordinates of the points. Now, but if you have a lot of points, then we want to know what the distance between the 2 clusters are. There are lots of ways to do this. One is taking the average, so you find the mean point and the mean point here, and then find the distance between that. Or we find the maximum distance, so there's a point here, there's a point there, and that happens to be the maximum distance, so you have to compute all pairs of the distances. Or you can take the minimum distance, that means the closest points, so the point here and a point here. So all of them are okay, but you can determine that strategy based on the kind of thing you're trying to solve. So we can use many kind of distance matrices, like metrics like Euclidean or Manhattan or others. And so we'll take a look at an example. So let's suppose that we have these points. Now these are points in one-dimensional points. All right, so they are located, assume that they are located on the x-axis. A is the point 1, and so on. So B is the point 2. So if you take this, and here's 0, and here's 1, and this is A, right? And the B is here, and that's 2. So by looking at it, it's kind of clear, but just by looking at the clusters, it's clear that 1 and 2 are close, and 4 and 5 are close, and 8 is kind of like by itself, right? Because the distance between them are like very small. So we'll see whether we will come up with that kind of clustering. So what we're going to do is we're going to create a matrix and compute the pairwise distances between data points. For example, between A and A is 0 because it's the same point. Between A and B, we just subtract 2 from 1, so that's going to be 1. A and C, we subtract 4 and 1, and then you get 3. So you get the idea. So we compute the distances between the points. Now what we're going to do is we're going to find each point and the closest point. For example, if you look at A, the closest point is B. So we'll put the A and B into one cluster. Now if you take C, the closest point is D. So we'll put the C and D into one cluster. And then the E is by itself. Right, so we haven't done. So we compute, now we went from individual points to 3 clusters. Now if you look at the clusters now, so we have C1, cluster 1 is AB, cluster 2 is CD, cluster 3 is E. And now what we're going to do is we're going to take a distance between the clusters. We're going to use the midpoint of each cluster as the cluster center. For example, if you take C1, C2, C3, those are the clusters. They all have the midpoints of the average. Like for example, C1 is A and B, and the midpoint between A and B is 2 plus 1 over 2, which is 1.5. Okay, same thing with C and D. The midpoint is 4 plus 5 divided by 2. That's going to be 4.5. And the 8 is by itself, so 8 is just 8. So we have that. Now we're going to compute the cluster distances between C1 and C2, which is 1.5 minus 4.5. Right, so we get 3 here. And then C1 and C3, we get 1.5 and 8. We get 6.5. And then C2 and C3, we get 4.5 and 8, which is 3.5. So after combining, now we have to combine the closest clusters. So we will look at C1 cluster and C2 cluster. We see that C1 cluster is closer to C2 than to C3. Therefore, we combine C1 and C2 clusters. And then the C3 cluster is by itself. And now we have A, B, C, D, and E. So if you do another iteration, we'll end up with the one cluster that contains all the points. That's the idea here. Okay, so that's the sort of the what we call the bottom-up clustering, and then the top-down clustering is very similar. Again, we compute. In this case, I'm using two-dimensional points, not one-dimensional points. And so when I compute the distance between, say, A and B, I'm looking at these 2 points and take the difference of x coordinates, difference of y coordinates, and then I'll take the absolute value, which is 2 minus 1, and that's 1, and 2 minus 1, 1, so that's 2, right? So if you take the A and D, for example, so I take A and D, so in this case, 8 minus 1 is 7, 8 minus 1 is 7, so that's how you get 14. So you get the idea, so you fill out the table. Now you can try to come up with the clusters, for example. So we start with all points in a single cluster. Initial cluster is A, B, C, D. Now we have to split into 2 clusters. So to split into 2 clusters, we are going to identify the group of points that are farthest apart. So for example, if you look at ABC, that seems to be very close to each other, ABC, and then DEF seems to be close to each other. So we have 2 clusters now, ABC and DEF. So it's just kind of clear if you look at the points manually, you will see that that's a cluster and that's a cluster. What we try to do is to computationally figure out what these things are. Now then repeatedly we are going to split the clusters. So we can take the cluster 1, which contain the points A, B, C, and then split it into 2 clusters. In other words, B and C are closer to each other than to A, so we put B and C into one, A into the other one, and the in cluster 2.1 we are going to say D and F are closer to each other than close to E, so we'll have D and F and E. So when we continue this, and so we continue until all points are in separate clusters. So we're going to continue splitting until stop condition is met. So that means no meaningful further divisions or predefined number of clusters. So we end up with the clusters A by itself, B and C in one cluster, and D and F in one cluster, and E is in another cluster. All right. So that's if you look at the 2 types of hierarchical clustering we talked about. We have the bottom-up clustering, which is each data points in a separate cluster, but the top-down is all points are in a single cluster. And then we merge those clusters iteratively, and then in this case, you're splitting clusters iteratively. So bottom-up is going up to single cluster, and top-down is coming from one cluster. So complexity is, this one is more commonly used because it's simpler to implement. The divisive clustering, which is we start with a single cluster and then we start to break it up, is a lot more expensive. Now, from a computational perspective, then the big O of the bottom up is n cubed, and the top down is 2 to the n. So you can imagine that you have like a tree of things that are coming down. So therefore, the computation is much better for the bottom-up case, which is n cubed is less than 2 to the n for large n. The result is focus on merging smaller groups to large one, focus on breaking large groups into smaller one. So in the next video, we'll talk about a summary of these ideas.